Okay, so last week, Qwen dropped the weights for Qwen 3.8 Max, and it's undeniable that this model is pretty amazing at what it can do. But the key problem with this is it's 2.4 trillion parameters. So there are very few people that are going to be able to run this locally. What everyone was actually waiting for was the model that dropped on Friday, and this is the Qwen 3.8-27B. So in this video, I'm going to look at the model and the benchmarks, etc. But more importantly, I want to talk about which version of this model you should be running and how you should be running it. Now, I've talked a lot on the channel about the Qwen 3.6-27B, that really in many ways that was sort of the darling model of a lot of people doing local coding, running local agents, etc. And we've even looked at things like ThinkingCap, which was a fine tune of that 3.6 model to basically get it to be more succinct in its reasoning tokens, but still keep the same amount of intelligence. And even last week, we looked at Glimmer 30B from Meta, which was benchmarking against the Qwen 3.6-27B model in a lot of their examples. And I made the comment at the time that they were possibly just trying to rush this out, knowing that the 3.8-27B was on the way and was likely to drop any day after that. Well, sure enough, that is pretty true. If we look at the benchmarks that actually came out for this from Qwen, we can see that this model is doing substantially better than Meta's Muse Glimmer model in here. And not only that, obviously it's doing quite a lot better than the Qwen 3.6 model. Now, I mentioned at the time that Meta was probably rushing that out, knowing that the Qwen 3.8-27B was going to drop any day now. And while I'm going to go through the benchmarks and have a look at this, most of this video, I want to look at which version of the model should you be running, because already there are lots of different fine-tunes of the model. There are also lots of different quantizations of the model. And perhaps more importantly, how should you be setting the model up to get the right balance so that it actually runs locally on your system? All right, so if we come in and look at Qwen's own benchmarks, you can see that the comments that I made back then about the Muse Glimmer were pretty much true, that this model pretty much surpasses Muse Glimmer. Now, I wouldn't totally dismiss Muse Glimmer. I think it's still a very good model. It's been trained a lot more for generalization than the actual benchmarks, so it's still worth testing for your actual use cases. And like I said in the video, I feel that that team is just getting started, so we're going to see a lot more versions of that going forward in the future. But back to Qwen 3.8. So if we look at this, it's a substantial bump over 3.6 in pretty much every area here. So if you were happy using 3.6, you're definitely going to get a nice drop-in replacement here. On top of that, they seem to have put a lot of effort into the vision performance in here. And we can see even things like computer use and stuff like that. This is actually beating out Opus 4.6 Max, which, to be fair, those previous Opus models weren't heavily focused as much on computer use and browser use as the newer versions have been. All right, so just as I've been recording, Artificial Analysis has released their intelligence index scores for this Qwen 3.8-27B model. And I gotta say, the results are pretty insane. This is scoring 52, which puts it not far behind models like the GLM 5.2 at 53, DeepSeek V4 Pro, and also just way ahead of the Qwen 3.6-27B model, and pretty much any other open model that you even have a chance of running without a serious investment in the hardware. The other thing is when we look at their agentic index here, this is actually beating out GLM 5.2, beating out some of the GPT 5.6 models. Again, this is pretty insane for a model that you can run locally and get a decent token speed out of it. But the key thing I think is really interesting here is which version of the model do you actually pick? Now, if we come into the Qwen 3.8 family on Hugging Face, we can see the 2.4 trillion parameter models there. But under the 27B, they've both got a bfloat 16 version, so that's kind of like their full resolution version, and they've got an FP8 version. On top of that, there are already 4-bit versions out from Unsloth using the NVFP4 quantization. And you should remember that not all the GPUs can actually run this quantization as well. And on top of this, there are already lots of different fine-tunes of this model already out there, where people are both training it on different data sets to get new results out of it, and then also where people are making sort of uncensored versions of the models. So there are some examples where people have done that through fine-tuning, and there are other examples of where people have done that through obliteration. So the Black Frost AI team was one of the first groups to do this, but since then there are also multiple obliterated versions out there. And of course, if you don't have access to an AMD or an NVIDIA GPU and you're running it on a Mac, the MLX community has already released multiple versions of Qwen 3.8 for MLX. And that includes things like the bfloat 16 ones, 8-bit ones, 4-bit ones, as well as MLX versions of the different kinds of quantization people have tried as well. So what I'm going to do is go through a few of the different versions I've been testing over the weekend. But more importantly, I'm going to show you that actually how you set up the reasoning is going to be one of the key things that determines whether this is a good model or a bad model for you. Okay, so I've been trying out 5 different versions of this model, and I'm running them on a Dell T2 Pro Max, which has kindly sponsored the compute for this. So all of these are actually running on an RTX Pro 6000 GPU from NVIDIA in here. And that's a pretty beefy GPU. So I've got 96 gigabytes of VRAM here to play with. So in my particular case, I have no problems being able to load the model, right? Obviously, that's a luxury. Many people are not going to be able to load the full 16-bit bfloat resolution version of this model. But I'm going to try out that version. I'm going to try out Qwen's own FP8 version in here. And then I'm also going to try out Unsloth's quantization. And I'll talk a little bit about some of the obliterator models that I tested out as well. So first up, whatever model that you pick, you're going to realize that it's not just about the quantization that determines whether this model is good or not. So let me show you a little simple exercise. So here is my standard sort of HTML test where I ask it to basically make a website. The joke is that it's Dario Wellness Retreat. I think a number of you can remember where that came from. But you'll see here that this is a version of the website that was made with no thinking at all in here. So it's done a pretty good job at just basically thinking turned off completely. And you can see when we come in and look at the results here, there are no thinking tokens, right? It just goes straight into generation for this one. If we look at the same thing for reasoning on with low thinking, you can see we get quite a different website, right? We're getting something that's still very nice. There's a lot of perhaps effects in it. And you may actually even like the version that had no thinking at all in here. And this is sort of what I'm trying to get at, is that the different levels of thinking consume hugely amounts of different tokens. So here, if we look at the code, we can see we got 512 thinking tokens. And this seems to be reasonably consistent when I've run it a few different times. Occasionally it gets quite a bit less, occasionally it gets more, and it will depend on what sort of task you're actually asking it to do. But here low is getting 512. So if we come in here and look at the medium thinking, you can see that this is kind of similar actually to the low one, right? So you would presume here that this is going to actually be using more thinking tokens, but actually it ends up using less. And I've run this sort of 4 or 5 times. I'm not sure why on this particular task. Medium thinking seems to be using less than low thinking here. Now, the question should be, well, what about high? Well, they don't really have high. They have X high thinking. And this is where the model goes nuts. You'll see here that I don't have a finished website to show you on this one, because the issue here is that while I've limited it to 32K max tokens out, I've actually run out because I've spent 17,500 tokens on thinking. Now, I've run this multiple times trying to get one that actually finished, and I've had the thinking tokens be as high as 22,000 thinking tokens. And if we look at them, it goes into insane detail in here. So while it actually produces a lot of the similar sort of colors and stuff as the other ones, it just talks to itself a lot about this. And this is a general consistent thing that I've noticed, is that if you're going to run this model on X high, you've got to be prepared that one, you want to make the context window very big. But two, you're also going to be sitting around waiting for the thinking tokens to actually process. And this seems to be true whether I'm running on the FP8, which I've done these examples on, but I've also tried this on the 16-bit model and on the unsloth model. And you'll see that for each of these on X-high thinking, you get insanely long amounts of thinking. Now, if we look at the same thing for the SVG test, right? So this is the generate a Pelican SVG test. I've taken this from Simon Wilson's tests, and you can see this is on X high. So we've got 11,000 tokens of thinking to get this. And it's not a bad version out. But if we look at the medium thinking here, we're down from 11,000 down to just under 1,000 tokens. But we can see that here we've still got a pretty good Pelican going on here. If we look at the low one, actually, again, we're over the number of thinking tokens of the medium one. And we've got a sort of similar one, although we're definitely starting to miss some of the details there. And sure enough, if we turn the reasoning off and just have a look at the straight one out with no thinking, we've got a pretty ugly Pelican, although at one stage this probably would have been considered really good. So the sweet spot for me seems to be having the reasoning on medium. And just to show you quickly how much it's overfitting on the Pelican example, here I've changed it to a red dragon. And you can see that it still can get the bike right on no tokens out, but our red dragon is kind of childish. If we go up to low thinking, we've got something that's a bit better. If we go up to medium thinking, you could even say that it's kind of regressed a bit on the dragon. Still pretty good on the bicycle, but not on the dragon there. And by the way, this time the low thinking actually is quite low. It's 420 tokens as opposed to medium, where it's actually doing 2,000 tokens here for the thinking. Now you can see when we go to X high, we're using 35,000 tokens, of which 21,000 were for thinking. Is it better? Yeah, it's probably better. I don't think I would say it is great. We've got a moon, we've got some sort of city backscape, we've still probably got a better bicycle and stuff like that. So yes, the X high will get you better results, but the amount of tokens is just kind of insane. So you can see that overall, I had to extend the token window, and it's used up 35,000 tokens, of which 21,000 here were thinking tokens just to get the dragon, which I guess is okay looking, but it's certainly not great looking here. All right, so now that you know setting the number of thinking tokens is really important. The other thing is which version of the model do you actually go for? So first off, I tested the basic bfloat 16 original version of it. And that was getting me somewhere around sort of 30 tokens per second. And that was just pure generation. Now, at that point, I had no speculative decoding going on, right? From there, it became pretty clear that you want to basically have the speculative decoding on, and you probably want to set it to MTP equals 3. So it's doing multi-token prediction for 3 tokens there. And that alone got me a good speed bump in actually running the model. Now, for running these, mostly I've been running them on VLLM. And the next version I went to was the FP8 version of the model from Qwen themselves. And this with speculative decoding was getting me around 80 to 120 tokens per second. And it works very nicely. I didn't really notice much of a quality difference compared to the bfloat 16 version. Again, this was using their built-in MTP model for speculative decoding. And if you've got that set up right, VLLM can just take care of that for you. Now, around this time, I also tried out some of the obliterated versions of the model. And while I found them interesting, and yes, they sort of open things up, I find that these versions often get into repeated loops on the thinking and just get stuck in that repeated loop. So honestly, probably at the moment, I wouldn't bother with using the obliterated ones. Next up was the unsloth model, and this had really good token rates. With the MTP, I was getting around 120 tokens per second here. Is very nice quantization of the model. I found it worked for a lot of the different tasks. And I kind of thought at this point, 120 tokens per second was doing pretty well. And that's when I came across SGLang's version of serving this model. So they are not supporting all the different hardware. They're really focused a lot more on the Blackwell GPUs. And you can see here that I've got it configured for doing the RTX Pro 6000, the FP4, and the D-Spark. And it turns out that taking everything else off the GPU and loading that in a Docker configuration was able to get me very fast speeds. And if you look at their X account, they are kind of showing this on their account, right? They're claiming here that you can get up to 206 tokens per second. And to do that, they're using a very particular NVFP4 model. I found that when I used their setup with the unsloth quantization, it didn't work as well. But with their model weights, sure enough, I'm getting much faster tokens per second. So you can see here, this is 36,000 tokens with an average of 173 tokens per second. And you can see that for things that are not too long like this, I can often actually get around 200 to 220 tokens a second. Now, I would say the average is probably a bit under 200 tokens per second, around 200, maybe a little bit below that. But at that speed, that's flying. I've got it running in a Docker container, which is using their particular image from their cookbook. It's the NVFP4 Quant from them with the D-Spark speculative decoding in there. And it's got the full 262K context window running beautifully in there. And you can see, even for things where it's using a lot of different tokens, I'm still getting average speeds of 150, 160, 170 tokens per second. So overall, just to finish up, I would say you really need to experiment with different versions of the model to see how it's going to work for your particular use cases. And then once you've got that model, the different configurations of the amount of reasoning tokens that you want to set, and it even turns out what inference library you want to use. So I tested VLLM in here. I tested SGLang. SGLang was the winner for this final configuration in here. But if you've got a GPU with a lot lower VRAM, you probably also want to test out Llama CPP. And I've got to say, on whatever you're doing the testing, give these pages of where people are talking about how to set it up and stuff like that to your coding agent and have it test out different configurations to see what works best for you. For me currently, if you can serve this model, this is the model to beat for local AI. It really is doing so well. The fact that the artificial analysis intelligence test shows it to be so high just confirms for me a lot of things I felt using it and testing it out. And I'd finish up by saying that I think it's going to get even better. I'm really looking forward to see, do we get a ThinkingCap version of this where it uses less tokens for the same amount of intelligence? Do we get other fine tunes that actually improve the intelligence? And do we get things like fused kernels where this ends up being able to be served at even faster tokens per second? So let me know in the comments how you're running this, what your current setup is, how many tokens per second. I may revisit this model with some tests on the DGX Sparks or the GB10s and show you with 1, 2, maybe even 3 machines what you can do there for this kind of thing. But clearly this is taking a huge step forward, both not only in open weights, but in local AI, where you can run these things on sort of prosumer hardware. So anyway, as always, if you like the video, please click like and subscribe, and I will talk to you in the next video. Bye for now.